welcome to Quick Concepts for Advanced Math 1. Today we're going to talk about equations of lines, how to find them, what it is, all that jazz. Equations of lines. So first of all, Algebra 2, Algebra 1, I always teach what I call slope-intercept form. So the slope-intercept form of a line is always going to be y equals mx plus b. Hopefully you guys know all about this, but just a little bit of a refresher. The m is the slope. That's how steep it is. If it's positive slope, it goes uphill. If it's a negative slope, it goes downhill. This is the y-intercept, and that's essentially where the line crosses the y-axis. So here's our y-axis. If you have a line that looks like this, right here would be the y-intercept. It's where it crosses the y-axis. Okay, so let's talk about some of the problems you're going to see here at the beginning of Advanced Math 1. Just a little bit of a reminder. So I am working through the example problems in your textbook on page 75. I'm going to be doing example 10.1, 10.2, and 10.3 for the equations of lines. So if you look at example 10.1, it says find the slope-intercept of the equation, which we know that's y equals mx plus b, that passes through these 2 points. So what you need to know in order to find something from 2 points is you need to know the slope formula. So if you don't remember this, please write it down on a card somewhere, but this is just going to kind of help you remember what to do. So now I'm just going to plug in. So y sub 2 is negative 3, y sub 1 is 2, x sub 2 is 4, x sub 1 is negative 3. So this becomes negative 5 over 7. So our slope is negative 5/7. So I'm going to go ahead and put that in. Now in order to find our y-intercept, which is our b, I'm going to take one of the points. It doesn't matter which. I'm just going to take this first one, and I'm going to plug it in for y and for x. And that way I can just go ahead and use algebra and solve for b. So this will be 15/7 plus b. I have to subtract 15/7 from both sides. So when I do that, I get b is equal to 2 minus 15/7. I need to get a common denominator, so that's going to be 14/7 minus 15/7. So b ends up being negative 1/7. Now I'm not done. Remember what they're asking for. They want the equation of a line, so I have to put it all back together. I now have my slope, and I now have my y-intercept. So that is the answer you were looking for. Now let's look at example 10.2 at the bottom of the same page. It says find the equation of the line. Now this time again it wants the equation of a line, but it passes through negative 2, 5, and it's perpendicular to a different line. So we need to remember what we learned about perpendicular lines. So if you don't remember, when you have two lines that are perpendicular, their reciprocal is the opposite. The slope is the opposite reciprocal of it. So whatever slope I get for this, I'm going to flip it upside down to make the reciprocal, and I'm going to take the opposite sign. So first I need to do is I need to get this into y equals mx plus b form so I can see what my slope is. So here I could see that this slope is negative 4/3, so my perpendicular slope, the slope that's going to go here, is going to be a positive 3/4. Again, I'm flipping it and changing the sign. Now I'm going to take my point that I was given and I'm going to plug it in and solve for b. So this one is 5 is equal to negative 6 over 4 plus b. If I add 6/4 to both sides, I get b is equal to 5 plus 6/4, which is b is equal to 20 over 4 plus 6 over 4. b is equal to 26/4, and we're going to reduce that to 13 over 2. Now, of course, don't forget to put everything back together. And this is your final answer. Now, you can have that same type of problem, but you can also have what's called a parallel slope. And just remember with parallel slopes, parallel lines, the slopes are equal. So perpendicular lines, they're the opposite reciprocal. Parallel lines, the slopes are equal. Okay, so if you flip over, we're going to read a couple lines and come up with the equations by looking at those lines. So this is example 10.3 on page 76. So give me a second. I'm going to draw these out just in case you don't have a book so you can see. So this is A and this is B. So we'll start with A. This is pretty easy. Whatever axis it's crossing, if it's a straight line, either flat or up and down, you just take that axis and you put it equal to wherever it's crossing at. So here it's crossing at -1, -2. So A is y is equal to -2. Now B is a little bit more difficult. And the reason I say that is because we don't really know where it crosses the y-axis, because if you look at the picture, it doesn't show that. So I'm going to have to use my slope formula to figure out it. So what I want to do is I want to pull 2 points off of this line. So I'm going to pull this one off. This one is going to be, actually that's not -40, so that I can't even use that one, but I can use this one. This one's definitely a point, and it's -1 and 6, so that's one of the points I'm going to use. Now I need to find another exact point. If I look at this. Okay, so I see one down here at -5 and -6. So 4, 5, 6, 4, 5. Yeah, so that's a perfect point there. So it's going to be -5, actually -6, -5. All right, so what we're going to do here, again, x1, y1, x2, y2. So -5 minus 6 over -6 minus -1. It's plus negative. That's -11 over -5. So this is 11/5 is my slope. So I'm going to plug it into the line. Oops, it's not negative. It's just 11/5. And then you can pick either of these lines. It doesn't really matter which. It's completely up to you. And we can plug in and solve. 11/5 times -1 plus b. So 6 is equal to -11/5 plus b. And then you add 11/5 to both sides. So b is equal to 6 plus 11/5. So this will be 30/5 plus 11/5. So 41/5. So y is equal to 11/5 x plus 41/5. And so that is your equation for B. So that's pretty much the equation of a line, just a little bit of a review here for my Advanced Math 1 students.